Hello everyone and welcome to another video. In this video we are going to do questions from the chapter inverse trigonometric function, and these are the 5 questions we'll be doing in this video. So let's begin with the first one. The question over here is sine inverse x is equal to theta plus beta and sine inverse y is equal to theta minus beta, and what we have to find out is the value of 1 plus xy. Now what we are going to do here, we need x over here. So from here we can obtain x, and what is x is equal to, we can see from here that x will be equal to sine theta plus beta on transposing sine inverse to the other side. And from here what is y is equal to, it should be sine theta minus beta. Now check, we have to get 1 plus xy. So if I replace, this is what we have to get, 1 plus xy is equal to, so what I can write 1 as 1 is 1 only, and x will be replaced with this and y with this. So it results to give you what? Sine theta plus beta multiplied by sine theta minus beta. And then we are going to apply this identity. The identity here is this. That is sine a plus b into sine a minus b is what? Sine square a minus sine square b. So this we can write this as 1 plus this can be written as I said, it can be written as sine square a minus sine square b. Well, a is theta over here and b is what? Beta. So this is sine square beta. Now further what you can observe from here, this is 1 over here. This is 1 over here, and this is sine square beta. So what is 1 minus sine square beta? That should give you cos square beta, right? So I can write this as cos square beta plus this as what? Sine square theta. So this would be the value after simplifying this. In this question it says 2 times sine inverse x is equal to sine inverse 2x into whole under root 1 minus x square holds good for, and these are the possible values of x given over here. So what we are going to do, look into this whole thing, which is what? A sine inverse function. And what is the range of sine inverse function? It is minus pi by 2 to pi by 2, right? So this is minus pi by 2 to pi by 2. The value of this will range from minus pi by 2 to pi by 2, which I can see it is equal to this. So what I can say that 2 sine inverse x, the value of this will vary from minus pi by 2 to pi by 2. Now check, we have to get the value of x. So first I am going to divide both sides with x. I'm going to divide both sides, not both sides, all sides with x. So it will result to give you minus pi by 4, and this is sine inverse by dividing with 2, and dividing this by 2 is pi by 4. Now if I this is what we have, then if sine inverse is this, then what is sine is equal to? Can I say that this is sine minus pi by 4 less than equal to x? And similarly on the other side, on transposing sine inverse x to the other side, it is sine pi by 4. Now here, now what is the value of x? What is sine inverse minus pi by 4? If I write over here, this is, say, x. What is this? This is minus 1 over root 2, and this is positive 1 over root 2. So I can see that it varies from, what we have to find out was, this is going to be modulus, right? So as you can see that we have a modulus sign over here. So we can say that this is same as this. So option C is correct in this case. As what? Pi over 6 minus sine inverse x by 2. Now therefore what is x is equal to? X will be equal to cos of pi by 6 minus sine inverse x by 2. So now I'm going to apply this identity, that is cos A minus B is what? Cos A cos B plus sin A sin B. Well, this is our A and this is B. So in that case, we are going to get this as x is equal to cos A, that is cos pi by 6, into cos B, and B is what? This is our B, that is sine inverse x over 2 cos A cos B, and then plus sine A sine B, so that is plus sine A is what? A is pi by 6, so sine pi by 6 into sine B, and B is this, that is sine inverse x by 2. Now continuing with this, we are doing on the now other side of the board. Let's say I do it over here. So what I can write, x is equal to, this is cos pi by 6 is what? Root 3 by 2. So this is root 3 by 2, yeah, this is root 3 by 2. And next this is cos into sine inverse x. So here we are going to apply this, that is sine inverse x can be written as what? Cos inverse under root 1 minus x square, right? So I can write, I can replace this one more time. This is what? Sine inverse x by 2. I'm going to write this in terms of cos. So let's say if I write this cos as it is, and I'm going to replace sine inverse x as what? Cos inverse under root, this is cos inverse whole under root 1 minus x square. And what is x? X is x by 2, so this is square of this, right? Then we have plus, and what is sine pi by 2? That's half, and sine into sine inverse x is x by 2. So now we have x is, now I'm going to transpose this to the left hand side, right? Or this is what? X over 4. So if I write this on the left hand side, this results to give you root 3 by 2 times of cos into cos inverse x is x. So this is what? On simplifying this, what I can write? This as 4 minus x square over under root 4, and under root 4 is 2. Now I can see that this is 4 and this 4, sorry, after taking LCM it can get cancelled. So let me write down in this. This is simplifying. This is 3x by 4. This is root 3 times 4 minus x square whole under root that divided by 4. Yes, now we can cancel this 4. So next is to do squaring both sides, right? I'm going to do squaring both sides over here. So on squaring both sides, this is how much? This would give you 9x square. So this is 9x square, and square of root 3 is what? 3, and square of this whole under root will be 4 minus x square. So even this can be cancelled, that is 3 1 times 3 3 times. So finally we got this as what? 3x square minus on the left hand side will be positive x square, which is equal to 4. So from here we got x square is equal to what? 1, or maybe x is equal to plus minus 1. Now we have two values of x. What you can do here, you can check for the values, the one which is satisfying this. So you will figure out that x is equal to minus 1 does it not satisfy this equation. Therefore our final answer should be what? X is equal to 1. So the value of x is 1 in this case. Now in this question we need to prove that 4 times cot inverse root 3 plus cosec inverse under root 5 is equal to pi. And to do so we are going to use this relation, that is tan inverse x plus tan inverse y is equal to tan inverse x plus y over 1 minus xy. Condition is xy product should be less than 1. Now we can use, one thing is clear, that we need to convert cot inverse x into tan inverse, cot inverse into tan inverse, and so is cosec inverse into tan inverse. And for that I am going to use this property of a triangle. Let's say if I make a right angle triangle over here. Now cot is what? Cot is base over perpendicular. So what is tan? Therefore tan is perpendicular over base. So we can say that cot inverse root 3 is same as tan inverse 1 over root 3. Now similarly we can do for cosec. Let's say cosec is what? Cosec is hypotenuse over perpendicular. Now applying Pythagoras, this is root 5 square is 5 minus 1 4, 4 under root is 2. So cosec inverse under root 5 is same as tan inverse perpendicular over base, that is 1 over 2. That's what we are going to apply in this question. So I can write this as, let's say this is our LHS. LHS is 4 times cot inverse. As I said, cot inverse 3 can be written as tan inverse 1 over 3, and cosec inverse under root 5 can be written as, in terms of tan, it can be written as tan inverse 1 over 2. Next we are going to apply this property, that is now once we have done this, I can apply this property. And what is tan inverse x plus tan inverse y is tan inverse x plus y, that is x is this plus y is this, over 1 minus x into y, that is 1 over 3 into 1 over 2. So this is equal to 4 times, this is tan inverse, on simplifying the numerator it is 2 plus 1 3, that is 5, right? This is 5 over 6. On simplifying the denominator, this is how much? 6 minus 1. This is 6 minus 1 is 5 over 6. So I can write this as what? 6 over 5. This get cancelled, and what it results to give you, this is 4 times tan inverse 1, right? And what is the value of tan inverse 1? Value of, I mean to say, the value of this tan inverse 1 is how much? It is pi by 2. Tan inverse is pi by 4, sorry, tan inverse 1 is pi by 4. So if we reduce it, we get pi, and we can say this is what? Equals to RHS. That's what we need to prove in this case. The question here is to find the value of cot inverse tan pi by 7. So what we are going to do is to write this tan in terms of cot. Tan, you know that tan theta can be written as cot 90 minus theta. So that's what we are going to do. Let's say if I write I is equal to, this is cot inverse, I'm going to replace this tan as what? I can write this as cot pi by 2 minus theta, and theta is pi by 7 over here. So this is I is equal to cot inverse. I'm going to simplify this part. So this is results to give you how much? The LCM is how much? 14. This is 7 pi minus 2 pi. So therefore I is equal to cot inverse, this is cot 7 pi minus 2 pi is how much? 5 pi over 14. Now what you need to check over here is this angle. The angle over here is what? This 5 pi by 14. Does it belongs to the principal value branch? Yes. We can see that pi by 14 belongs to 0 to pi. Therefore we can write this I is equal to, what is cot inverse into cot? X. Cot inverse into cot x is x, and therefore I can write the final answer as to be 5 pi by 14.